Hi, I'm Sean. I'm a H1 maths student and I'm studying maths in college. And I'm here to help you get through your Leaving Cert maths questions. So let's get into it.
So here's our question. We're told that Connor's property is bounded by the straight bank of a river as shown in figure 1. We're told that T is the base of the vertical tree that is growing near the opposite bank of the river. So TE is the height of the tree as shown in figure 2. From the point C, due west of the tree, the angle of elevation of E to the top of the tree is 60 degrees. From point D, which is 15 meters due north of C, the angle of elevation to E is 30 degrees and the land on both sides is flat. Okay, so for part A, we're told to use the triangle ECT to express TE in the form root ACT meters, where A is a natural number. So we're trying to express TE basically in the form root ACT. So if we go back up to our diagram and find the triangle, we can see that it's this triangle here on the edge. It's sort of created obviously by ECT. You know, it's 60 degrees. The angle of elevation, I should say, from C to E is 60 degrees. So we're going to use the fact that the angle of elevation at C is 60 degrees to create a relationship between that angle and the opposite side, which is the length TE. And we also know that at this angle in here, sorry, I'll just put it in there, this corner is 90 degrees because TE is vertical. So E is the top of the tree and T is sort of the bottom of the tree. Therefore, we've got a simple right angle triangle. And we know one of the angles be 60 degrees. So given that, and also given the fact that we're trying to relate TE, which is opposite of 60 degrees, to CT, which is the adjacent of the angle 60 degrees, we're going to use tan 60 is equal to the opposite over the adjacent. So therefore, tan 60 degrees is equal to TE over CT. And we can use the calculator to figure out the value of tan 60. So we'll just go tan 60 and the value is root 3. So therefore we have TE over CT is equal to root 3. And we can just multiply across by CT. And we can see that TE is equal to root 3 CT. And that's it for part A. So that's worth 10 marks. And moving on to part B, we're asked to show that TE may also be expressed as root 225 plus CT squared all over 3. So we're looking for more information about TE. So if we go back up, we've already used all the information we can find from this pink triangle, but if we just get rid of that for a second, we're now going to figure out what we can tell about ET or TE, whichever order you like, based on this triangle, EDT. So we can say that TE is equal to DT times tan 30, because obviously this angle is 30 degrees. TE is the opposite and DT is the adjacent. So we'll just set up that relationship now. So that gives us this equation here. And to be clear, we're just doing this because this is the only other thing we can say thus far about TE. But now we've introduced this variable, or sorry, the line DT, we're going to see what else we can tell about DT. So if we go back up to our diagram once more, we can see that DT is also part of the triangle CDT, which is this triangle here at the bottom, which is now in pink. And this triangle also contains a right angle at C. So we can now set up the equality between DT to be squared, which is opposite the right angle in this triangle, plus is equal to 15 to be squared plus the length CT to be squared, which is over here. And that's going to get us closer to what we want, which is an equation between TE and CT. Therefore, by Pythagoras' theorem, DT to be squared is equal to 15 to be squared plus CT to be squared. And now we're just going to square that 15 and also get the square root of the right hand side. So therefore, DT is equal to the square root of 225 plus CT to be squared. So now we're going to plug our value for DT back into the original equation involving TE and see what happens. So that will give us this fraction here. But of course, we can also figure out the value of tan 30 with the calculator. And the value of tan 30 is equal to root 3 over 3. But I always prefer writing it in the form 1 over root 3 because those two things are the same. And just in case you're wondering exactly why root 3 over 3 is the same as 1 over root 3, if you have root 3 over 3 and divide on the top and bottom by root 3, you'll get root 3 over 3, or sorry, root 3 divided by root 3 on the top, which is 1, and 3 divided by root 3 on the bottom, which is root 3, obviously because root 3 by itself gives you 3, so therefore it's just the same thing. So now we pretty much have the equation that we want. We're just going to reorder it a bit. So because we want to isolate TE, we're going to multiply across by what's on the bottom line here, and that is going to give us the square root of 225 plus CT all to be squared divided by root 3. But of course, if you have the square root at the top and bottom of a fraction, you can just write it as the square root of the whole fraction, which means that we have what we wanted, which is the square root of 225 plus CT3 squared, all divided by 3. So that is our final answer. So a little bit tricky there for part B, and you can tell that it was because it's actually worth 5 marks in the exam. So I would definitely say that they found out people didn't do so well in this. So definitely a good question to practice. So now they tell us to hence find the value of CT and to give our answer correct to 1 decimal place. So they're basically asking us to do this because we have 2 separate equations involving TE and CT, and we can just let both the right hand sides of each equation, which come from part A, and also here from part B, equal each other, and then we're just going to try and isolate CT. So now what we're going to do is we're just going to square both sides of this equation, and that is going to give us this equation now. And just make sure that you square your CT on the left hand side, because if you don't, you're obviously going to be wrong and you're going to have a quadratic, and it's just going to get very messy. And one kind of confusing thing, I should say, from the marking scheme in this question is that they just jump from this line up here. And one quite confusing thing about this question is that they just jump from this line up here, the first line, straight to the answer, which I think is kind of annoying if you're a student, because it's not really obvious how you get there or what happened. But basically we're just going to try and manipulate this equation properly, and I'll show you how to what they got to in the marking scheme. So we have this now, we're just going to multiply across by 3. That is going to give us 9 CT squared is equal to 225 plus CT squared. And now we're just going to take away CT squared from both sides, which is going to give us that 8 CT squared is equal to 225. So now we're just going to divide across by 8 and also get the square root of both sides. So that is going to give us that CT is equal to the square root of 225 over 8. And that is equal to, just using the calculator, we can type it in, and it is equal to 5.3033. But of course, to 1 decimal place, that is just equal to 5.3. And don't forget to include your meters. So that's it for part C. Basically just manipulating the equation and seeing how you get CT, but that's going to be worth 10 marks. So now in part D, they say to find TE, the height of the tree. So now in part D, they ask us to find TE, the height of the tree, and to give our answer correct to 1 decimal place. So that's really easy, because we know that TE is equal to root 3 times CT, which is equal to root 3 by root 225 over 8. And I would actually recommend that you don't take the rounded off answer from the previous part, because that might actually give you something that's not accurate to 1 decimal place, because it is rounded off. So just to be on the safe side, I would always take the more precise answer, which is this square root over here. But root 3 by the square root of 225 over 8 is going to be 9.18 roughly. But of course, to 1 decimal place, that is equal to 9.2 meters. So that's it for part D. A very, very simple part of the question, given that we have an equation in part A which just directly relates these two things. So really straightforward. However, one thing I will say about this question is that it's pretty much all for nothing. So if you get the wrong value of CT to begin with, or you go wrong in part A or B, this is all going to very quickly go downhill. So don't feel too bad if this didn't turn out properly for you, because there's a lot of places to make a mistake here. But part D is going to be worth 10 marks as well. So now moving on to part E, we're told that the tree falls across the river and hits the bank on Connor's side at the point F. And we're asked to find the maximum size of the angle FTC to give our answer in degrees correct to 1 decimal place. So if we just go back up to our diagram once again, and we just look at figure 1, we're trying to find the maximum size of the angle created by this line FT and the line TC, so that is in here. And this angle will be at a maximum. The length FT is the same as the length of the tree, which we know is this height here, which we now have been calling TE. So if TF is the same length as TE, that will tell us that because of this angle in here, FTC, which we will call theta, would be the adjacent over the hypotenuse, which would be CT over ft, because we know that this angle in here is a right angle because t is opposite c and f is directly down from the point c. So then we can set up this equation and basically substitute in te and then see what will happen. So we have cos theta is equal to ct over ft, and we said that the angle will be at a maximum when the entire tree lies between the two banks of the river. So the tree just about falls at the edge of the river, and that is the point F, which means that ft can be written as te. But we also know that te from part A is equal to root 3 times ct, which means that we now have root 3 times ct on the bottom of the fraction, and of course we can cancel our ct on top and bottom, which means that we have 1 over root 3 as the value of cos theta, which means that all we've got left to find is the cos inverse of 1 over root 3. So we can just press shift cos on our calculator and go 1 over root 3, and our answer is 54.7 degrees, correct to 1 decimal place. And that's our final answer. The key thing here is to realize why we can sub in te for ft, and that's because we basically want the tree to barely touch the point F on the other side of the river. So that's worth 5 marks. So for part F, we're told that the tree is equally likely to fall in any direction now. So if that's true, we've got to find the probability that would hit the bank on Connor's side when it falls, and to give our answer as a percentage correct to 1 decimal place. So if it's equally likely to fall in any direction, we're going to treat its area where it could fall as a circle. So we have a circle, and we know that if it falls within a certain range at the left of the circle, so like over here, and it falls in this range on the other side of the river, then it would land within the range we're trying to figure out basically as a percentage. So what we want to know is exactly how many degrees this portion takes up. So if we have a tree falling, we want to know how likely it is to fall in this range, or the value of the degrees in there. So if we go back up to the diagram once again, we know the maximum size of the angle it can be in order to actually touch the other side of the river at all, and that's equal to theta, which is equal to 54.7 degrees. So there's no reason why we can't say the same thing about the other side, namely that there's a point over here somewhere where the same angle across will result in it just about falling on the other side of the bank, but if it were to go any further in this direction around, then it would just fall into the river. So therefore our answer is simply that we accept any case that happens within 2 times 54.7 degrees on the leftmost side of the radius, and that means that our little doodle here, if this was the radius that the tree would fall in, for it to be on the other side of the river, this would be 2 times 54.7, which means that the probability, which we're going to call P, is equal to 54.7 times 2 over 360, which is the total range of degrees it could land in. So 54.7 times 2 divided by 360 will give us 0.3038, which correct to 1 decimal place, and as a percentage equal to 30.4%. And that's our final answer. So that's it for part F. And that is it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources if you're feeling a bit stuck. So I hope you enjoyed it. Make sure to practice this type of question because this comes up all the time. And I'll see you next time.